आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you all a podcast series on STEM popularization. That is, science, technology, engineering, mathematics, and medicine. Supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation. Creative content and technical support is given by Farzeen Sultan.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
सोचिए, एक ऐसी जगह जहाँ ग्रेविटी का पुल इतना स्ट्रांग हो कि कोई भी चीज वहां से एस्केप ना कर सके, और ना ही इवन लाइट। ऐसे वक्त में आप अपनी आंखों से स्पेस टाइम का फैब्रिक हिलते हुए देख सकते हैं, जैसे एक इनविजिबल लेयर हो जो सब कुछ अपनी तरफ खींच रही हो। जब भी कोई ऑब्जेक्ट ब्लैक होल के पास आता है, उसके अंदर जाने का एक ही रास्ता होता है, वो है टाइडल स्ट्रेचिंग। ये बिल्कुल इलास्टिक स्ट्रेच की तरह होता है। आपकी बॉडी एक तरह से स्ट्रेच हो जाती है, जैसे आप किसी कॉस्मिक पास्ता में बदल गए हों। और जब आप उस ब्लैक होल के इतना करीब जाते हैं, टाइम अपने आप धीरे हो जाता है। आपके लिए वो 1 सेकंड हो सकता है, लेकिन दुनिया के लिए वो 1 घंटा या 1 दिन भी हो सकता है। स्पेस और टाइम का नॉर्मल परसेप्शन बिल्कुल ही ब्रेक हो जाता है। इवन ब्लैक होल के आसपास जो मैटर होता है वो इतना हॉट हो जाता है कि एक एक्रेशन डिस्क बन जाती है, जो अपने अंदर हाई एनर्जी रेडिएशन जनरेट करती है। ये रेडिएशन हम तक एक्स रेज और गामा रेज के फॉर्म में पहुंचती हैं, जो ब्लैक होल की मिस्ट्रीज को समझने में मदद करती हैं। ये सब कुछ जानकर लगता है कि स्पेस और टाइम के फंडामेंटल्स को समझना हमारे लिए एक पजल है, जिसे सॉल्व करने में हमारे साथ बातचीत जारी रखेंगे एरीज यानी आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशनल साइंसेज में साइंटिस्ट जी के पद पर कार्यरत डॉक्टर इंद्रनील।
सबसे पहले जानेंगे सर की ये रिसर्च ग्लोबली कॉमन मैन और स्टेम के लिए कैसे यूजफुल है। आइए जानते हैं।
Let me say what I do first. So basic what I work on, as I said that this what gravity does, it stretches and it squeezes and it basically makes the things around it, if you have a strong gravity, into let's say a fluid. So the matter around a black hole or a neutron star acts as fluids, like our, not like our water. Water is a non-relativistic stuff, very hot, moving very fast, and so on. So what I do is I study fluid mechanics, the same laws of motion with which we study water in our pipes, or how the river is flowing and so on, or our air is moving around. I do the same thing, but now in strong gravity, in general relativity. When I say that, it sounds very esoteric. But if you directly ask me how it is going to help a man on the street, the direct answer is it will not help a man. But let me give you some example. What happens? Science is a curiosity-driven job. So you are curious to look at things. Now I gave you an example that the Schumacher-Levy is being stretched, and same thing happens with our tides. So when you are looking at the fundamental level, at the far reaches extreme condition, what you are trying to understand, you get a bigger picture, a larger picture of what is going on around in our universe. And that has, as a tertiary effect, comes into technology. For example, when the space race began between Soviet Union and Russia, who can go to space, like to the moon, but when you are sending those satellites and doing all those things, you need a communication. How will you control them, right? So the radio communications become better. And a very tertiary effect of that is our mobile. Again, I said that I work in general relativity, so it's like, again, it's very esoteric. I can, of course, give you, I can explain it in a very simple terms. That's what I try to train myself, be able to say, to give the basic idea to a person who is not a physicist. But still, the math is very, so it's, if I lay down those math, I mean, people will run away. That's true. However, the conclusions of special relativity and general relativity is something called time dilation. What it says, that if someone is moving, okay, let's say for special relativity, if someone is moving, running away from you, the clock he carries, time interval, let's say 1 second in his clock, will be, when you measure the same time interval, you will measure it longer, okay? You will say, no, it's not 1 second, it's something more. Let's say 1.5 seconds or 2 seconds or 10 seconds. So you will say that his clock runs slow. Again, if you are near of gravity, let's say I'm on Earth, I have my clock, right? It is ticking and so on. So let's say these are absolutely perfect clock, okay? There is no mechanical problem. So I will say this is 1 second, 2 seconds, and whatever. Now, if I go far away from Earth, and let's say there is no other gravity, let's say I've gone to outside Earth's atmosphere, my clock will run if I go up, my clock will run faster. So again, the 1 second measured close to Earth will be measured far away from Earth is more than 1 second. So let's say whatever, 1.5, 2 seconds, etc. This is called time dilation. This comes because of the constancy of speed of light. If the speed of light is constant, this happens. It can be shown again very easily. But these facts, which is very esoteric, right? These are the corrections that are made for our GPS to work. Because you know what GPS is, that you have a GPS, whatever instrument you have. So that will give you a radio signal to 3 satellites, which are also moving. So when they are moving, that means they did special relativity. And because you are closer to Earth, on this Earth's surface, and they are far away, therefore to them, you are in a stronger gravity, right? So your clocks and their clocks will not match. You have to make those adjustments. And again, you need 3 for triangulation to locate something. And these 3 satellites are also moving with respect to each other. So make all those corrections with pinpoint accuracy. You can now predict whoever it is, how it is moving. So it is always a tertiary effect, in which, not even a secondary, as I said, it's a tertiary effect in which it will go into technology, and therefore it will help common man.
सर की इस फील्ड में इंडिया के कंटेम्पररी और कॉम्पिटिटिव कौन सी कंट्री हैं, आइए जानते हैं.
India is a very fascinating country. Everybody knows that, because somehow it looks very, no system seems to work. Somehow we managed to produce excellent people. And this is historically so. Like Chandrasekhar, when Chandrasekhar was doing, it was under British rule. It was a very poor country. And yet we produce someone like Chandrasekhar in physics, Ramanujan in mathematics. We don't know how we managed to produce them, but somehow we do. And we give a very lasting impact. Chandrasekhar's contribution is, you can't say it, how big a contribution. Each of Chandrasekhar's books you can pick up, and you can start doing research on it. With that, you can start new research based on those, and people are doing that. In fact, to the extent that one of the satellites, extra satellite, is called Chandra. So, but then not only just him, he is a delta function, but not only him, there are many. We had like Visheshwaraya, Balai, Dhurandhar. They worked, they had stellar contribution in gravitational waves. That is, if gravitating objects are rotating around each other, or collapsing, merging with each other, it will give a space-time ripple. And they worked on it, and they had stellar contribution. That is well accepted in the world. Then my field, black hole astrophysics, relativistic astrophysics. There's Ramesh Narayan, who is now in Harvard, then Sandeep Chakrabarty. Both of them sort of during 1990s to 2000. They gave 2 competing theories, and they were absolutely recognized. Again, now a lot of people are also having their contribution in building up numerical simulation codes. Bhargav Vaidya is there in IIT Indore. We are also here in ARIES, we are also doing it, training many students. We have written a few numerical simulation codes, which are very good. I proposed thermodynamic relation for relativistic gas about 10 years ago. And that is being recognized now. A lot of people are using them. and I've implemented them in numerical simulation codes, and we're doing it. We have from our so essentially those matter that flows around black holes, it not only falls, lot of them are ejected at very high speeds, and these are called astrophysical jets. They move almost close to the speed of light. How would you produce such high speeds? And these are very big, they're very large. So, I mean, the central part of the galaxies have black holes, which are massive black holes, supermassive black holes. Like these are like billion times or million times the mass of our sun. So but those jets, they shoot out from the galaxy itself. So how do you maintain such a structure? So these are mysteries yet to be solved. So people thought that it is the magnetic field that it's powering those jets. We proposed an alternative method where we could very high speeds, we could generate high speeds. So what would say we are competing with international community, we are taken fairly seriously. But then again, we would have want more people to be working in this field. So because what happens is, like, if you have many people working, then it makes them larger. Like for example, in 1970s, 80s, 90s in US or Japan, a lot of people are working. So the focus is there, right? So a lot many people are working now than it used to be 20 years ago. More people are working in this field, then the focus will come back. And people will say, okay, so India is giving a lot more, producing a lot more. It's not like 10 people or 20 people working. They're good, but they're 20 people. We are in a good position, but it could be better if we can produce more students, research students.
इंडियन इंडस्ट्री इस रिसर्च से कैसे एसोसिएटेड है, आइए इसके बारे में जानते हैं.
So in theoretical part, I don't think Indian industries are collaborating. But in case of when we, for example, India is part of TMT project, this 30-meter optical telescope that is supposed to come up. In that, for mirror fabrication, L&T was, and then India is in SCA, that is square kilometer array coming up. So Indian industries, we are finding. So Indian industries are contributing when we are making observational facilities. But what we can say that when we are producing a lot of students, like for example my students, they generally become very good in computer simulation. So but if one of them don't choose to be in academia, it can very well go into oil industries, because it's like fluid mechanics, how the oil is flowing, where is the water flowing, or they can go into river technology or weather. I mean, I can regenerate. They can easily go into weather prediction, and I know a few people who have gone into weather prediction. So it's not just we are trying to produce scientists. It depends. I mean, you today you are interested in science, tomorrow you may not be interested in science. You might go and want to do something else, and you can do that. Theoretical physicists are going into share market. Their theories of probabilities into share market. So all kinds of things are there.
अब जानेंगे इनके आर्टिकल्स, रिसर्च पेपर्स और जर्नल्स के बारे में.
I publish mostly in the top journals. Okay, like the topmost journal, regular journal, is Astrophysical Journal, which is published by American Astronomical Society. Then there is another called the Monthly Notices, which is the Royal Astronomical Society from Britain. And then there is ESO, that is European Astronomical Organization. They have a journal, Astronomy and Astrophysics. So these are the top three journals. Other than that, there is PASJ publication from Japan. There is also a PASA, which is a publication from Australia. These are slightly in the lower, but they are quite good. So these are like top journals. And even, for example, you might have heard that the center of our galaxy and the center of another elliptical galaxy, M87, has been imaged recently, called the black hole shadow, and those papers were published in Astrophysical Journal. Thank you very much.
अभी आपने सुना हमारा ये खास कार्यक्रम. हम उम्मीद करते हैं कि आपको ये कार्यक्रम पसंद आया होगा. अब मुझे दीजिए अनुमति. नमस्कार.